Welcome back to Uncle Fish. Today we are going to finally write our very first program. If you have not checked out the Foundations of Programming playlist, I highly recommend to do that first before getting to this particular video and lesson, because again that will provide for you a really good foundational understanding of like what's happening inside programming. We'll touch upon some of those concepts that we went over in those videos here as well, but again it's recommended for you to listen to those things prior to writing your very first program. Alright, so let's get right to it. What are we going to talk about today? We're going to talk about and illustrate how to write our very first program. You'll see this in other places as well. We're going to basically print out something to the screen, right? A hello world type application. But before we do that, let's just talk about the high level steps of what we're doing, right? So we're going to have a source code that we're developing in some file. We're going to store that in a file. We're going to take that source code, we're going to compile it. And once we have that compilation, we're going to run it and hopefully see some magic happen, right? And that magic in our case is going to be printing something to the screen. So what's happening though, right? In the source code is a file that we're going to create. And in that file, we are going to write some human readable instructions. Whoops. And I'm calling them human readable because remember, C++ and these other languages are your higher level languages that are intended to be human readable. So again, in our case, it's C++. We'll write those particular instructions, and then we will go on to step 2, which is to take that source code and feed it into a compiler, and that compiler is going to then convert or translate that source code into machine code. So if you haven't seen the videos before, machine code is just basically your binary, your zeros and ones, something that is very low level and down to what the computer, CPU, and the components of the computer are going to understand. Once we have that, we should end up with the output of this compilation step is going to be a program, and we're going to go execute that program. And again, we should see some output, something that should be printed out to the screen in our case. Okay, so I hope that makes sense. Let's get to it. We can go see what that source code looks like. So instead of having everyone watch me type, I wrote this earlier, and we're just going to paste it in here. We'll see how this works, and then kind of mark up the image to explain all of the different steps that are going on. All right, so at the very highest level, this is the source file. So we created a file. I named it hello.cpp, CPP for C++, but this is our source file. This is where we're going to store all of our source code. And that code is this whole thing here, this body here, okay? So this is our source code stored in that particular source file, and we are then going to, again, when we go compile it, we're going to feed this file into the compiler. All right, great. So let's look at what is happening inside of this source code. Again, if this is your first time programming, you might look at this and say, what's this guy talking about? I don't know how this is exactly human readable, but it will be in time as you get a little bit better understanding of this and you practice and you write more programs. This is in fact human readable, especially when you compare it to the ones and zeros that we see in the machine code. And then I'll also show you some assembler code, that kind of intermediate phase, and you'll see how this is in fact really is considered a high-level human readable language. All right, so just like with any language, there is syntax, there are rules, there are things that you have to follow to make sure that we can make sense of that particular language. And again, programming is no different. So we'll talk about some of those pieces here. All right, so this thing here from this line 3 down to line 9, this is our function definition. Okay, and what we're defining here is a function named main. And every C++ application will have this main function. And we talked about this again in the other videos, but this is basically the starting point of your program, of any program. Your program can be 1,000,000 lines long, it can be 5 lines long. It will have a main function because we have to be able to tell the computer that this is the starting point of the instructions, and then from this starting point, go do these other things, okay? All right, and from a syntactical perspective, we have to give these things some boundary, right? So this main function has an open bracket and a closed bracket. And this signifies that the function body, which is these things, these commands basically, belong to that function main. Okay? And again, we'll talk about, like, you see these, commands here specifically, and you'll see that they are terminated with a semicolon. Again, this is syntax and rules. If you've ever heard the statement before, why these things are important, for example, is the sentence, "Let's eat grandma," which sounds like an awful thing, both for the person eating and also for poor grandma, when in reality, the statement should have been, "Let's eat, comma, grandma." And we can see just how important this comma and following these rules are to conveying the right information in the language. So obviously this is something totally separate from this. So following the rules of the language is really, really important, not just in English, but in programming, just the same, right? So where we put a semicolon, when we miss a semicolon, where we put an open bracket or a closed bracket, we are giving instructions and commands down to the assembler piece of this. So that assembler then uses these to ensure, hey, this is the beginning of this and this is the end of it. Okay, so I hope that makes sense. Understanding the syntax and the rules is extremely important in any programming language. Okay, so we've talked about the function name main. We've talked about the boundaries here. What is this int thing? What is that talking about, right? So int is actually integer, basically meaning a number, and this is the return type of the function. So in our example here, we expect that after we run this whole thing, that we will get back some number, right? That there's a return type of an integer here, right? And so this integer type is then tied to this statement down here, that once I finish this command, I want to return 0 back to whoever called this function. So interesting, right? So what's the 0 for? Why 0? What does that even mean, right? So what's happening here is we are returning this 0 value back to the caller. So in our case, the caller is the operating system. If you're running on a Mac, it's Mac. If you're running on Linux, it's Linux. It's Windows, right? But when the operating system is executing this particular program for you, once it succeeds, the return is going to be a 0 to the operating system. What does 0 mean? 0 is reserved, in this case, to the operating system for success. I ran the program and everything went fine. You don't have to return a 0. We could have put a 1 here, but that would tell the operating system that some general error happened. And hopefully in our case, we write really good code and there is no error, right? You can do other kinds of things. I think there's there's even a custom error that you can pass, but you get the idea, right? So we're telling it we have a function named main. We're telling the OS as well that when you leave and finish that function, return back to me, and I'm expecting something of a type int. Later on, we're going to learn lots of other things. You can return other types of returns, meaning like strings or non-integer basically. But this is again in the main case. If you wrote it any different, you would get a compilation error in C++. Okay. So finally, we get to this command. Well, almost finally. I think there's one other piece here. So before we talk about this command, I just want to highlight one particular thing. When we're giving instructions in this program to the computer, we're also giving instructions to be able to go print something to the screen, right? In this particular case, what we're saying is we want to take the word hi or the phrase hi Uncle Fish and have that printed out to the screen. Okay, great, but the screen is another device, and how do we know how to interact with the screen or tell it, hey, go print this, go do that? And we likely don't know how to do that, and if every developer had to go learn all of those details of how to interact now with a network device or with a keyboard or with your screen or any other input device like a disk, we wouldn't get a lot of programs written, right? So along the way, we get to take advantage of the work of others, right? Of other programmers. And so this is a really good example of that. So this, we're gonna come back to this, but this sentence here of pound or hashtag include IOStream. I guess it's not a sentence, but this phrase of IOStream is essentially telling the C++ compiler that, hey, I need some help here, right? I don't know all of these things on how I'm going to interact with the screen, so I want to use a helper here. I need to borrow from some other code to help me do something. So in this case, what we're saying is literally, hey, go find this IOStream. IOStream is input-output stream. You can imagine it's an input and output, so I'm going to be able to maybe write to things, right? Read something or write something. So go get this and literally copy and paste it, essentially, okay? Like, get it from wherever, and I want to use it in my particular code. Okay? So we'll talk about like what that is in detail later on, but that's really essentially what you're doing, is you're asking for a helper here. And now when you do this, then you can do things like use cout, right? And you can do things like this end L, which is also inside of that particular namespace. But you're borrowing cout. We didn't write cout. Someone else did. Okay? And cout in this particular case is what is literally writing your hi Uncle Fish to the screen. Hopefully that makes sense. So we have this here as our code that we're going to use to get help. So now let's finally talk about this last thing here. This is really the main command that this whole program is doing. So what we are saying here is, in the standard namespace, we'll talk about that in subsequent videos, but again, this is just the first level of it. In the standard namespace, there is an object called cout, and I'm going to pass the phrase hi Uncle Fish into cout, and then I'm going to pass a end line after that, meaning a carriage return, basically, okay? And that's it. So I just want to print this out, and once that's done, return 0, program is finished, and we're done, okay? So if all of that makes sense, let's go see this in action. For that, we have I have a Linux machine that I'm running. Again, if you're in school, you're gonna have likely some kind of an IDE. If you're at a fancy school, you might get a license to like CLion. Some campuses or schools will do this kind of compilation online, right? They'll allow you to do it online. So here I'm using Linux, and we have in here a file called hello CPP. Let's go look at that file. It matches exactly what we were talking about in the screenshot. Okay, great. And as we mentioned before, I'm going to take the compiler G++, and I'm going to tell it, hey, I want an output, and I'm going to call it, we can call it my program. Oops. Right? And the input to this, like where's my source code, is hello CPP. In Linux, you can tab and it'll fill it out for you. So that's what we're going to do. And our hope is, if we don't have any errors in the code, that you're going to get nothing in return, meaning that it compiled. And if you do an ls is just a listing of directories. You'll see now I have a new file here called my program. That's awesome, right? And we can go run it. So let's go run it. Now, what do you expect to happen when we run this program? I'm hoping that we should see our phrase, hi Uncle Fish. And we do. Awesome. And again, back to the operating system, they should have gotten a return of 0, which means that the program was successful and no error happened. So there's one other really kind of neat thing that you can do with this, with G++. You can say G++-s and pass it the source code as well. And something different will happen here. You'll notice now that I have a hello.s file instead of this our source code file, which is CPP. And I already have this in another window, so let's go look at what that is. And what this is, let's reload it, is the assembly language for our very simple program that was printing something out to the screen. And you can see just how complicated the assembly is for this one command, right, that we're executing. And again, the compiler is going to then take this instruction set and convert it into binary for the CPU to actually go and execute for us. But let's spend just a little bit of time on what's happening here. So this dot architecture is referring to the architecture of the computer that I have. And it happens to be an ARM, which is RISC-based architecture. Again, if these terms are not familiar, please go check those other videos out, the foundations of programming, and they'll kind of give you some of that background. right? So we're defining in here a string. Here's our string that says, "Hi, Uncle Fish," right? We're telling you that there is a function that we're going to go off and execute, and that function is main, right? So global here is going to basically saying, hey, this is the starting point of it, that this thing is of a type of function, and then here's the function definition basically. We're going to start the processing. You'll see these move, and I think BL was also like a linking, if I'm not mistaken, or a branch and link. So anyway, we won't go through too many of these details, but you can see what's happening here, right? So we're able to start the program. We're going to move the string into a register. We're going to call, like link into these other libraries. This was the basic output stream. Remember the pound include that we talked about with IOStream, and you'll start to see some of the commands that are within that we are using. So you actually should see something in here that's calling cout explicitly. Yeah, so there it is, right? So this is what's happening kind of under the covers. And so understanding this level, at least having an appreciation for it, I think will then make you realize that, hey, this really is a high level language, and this really is going to be human readable, right, as we go. So anyway, I hope that is helpful. We will continue on in the next lesson and start to write some more complex programs and add variables and other types of things. But this basic understanding, I hope you spend some time on it to really get on a good footing before we go on to the rest of the content. Thanks for listening, and stay tuned.